FreeBSD is a free Unix-like operating system descended from Research Unix via BSD. Although for legal reasons FreeBSD cannot use the Unix trademark, it is a direct descendant of BSD, which was historically also called BSD Unix, or Berkeley Unix. Due to its permissive licensing terms, much of FreeBSD's codebase has become an integral part of other operating systems such as Juniper JUNOS and Apple's OS X. FreeBSD is the most widely used open-source BSD distribution, accounting for more than 3/4 of all installed systems running open-source BSD derivatives. FreeBSD is a complete operating system. The kernel, device drivers, and all of the userland utilities, such as the shell, are held in the same source code revision tracking tree. Third-party application software may be installed using various software installation systems, the two most common being source installation and package installation, both of which use the FreeBSD port system. History: FreeBSD development began in 1993 with a quickly growing, unofficial patch kit maintained by users of the 386 Bahamian operating system. This patch kit forked from 386 Bahamian and grew into an operating system taken from UC Berkeley's 4.3 Bahamian light tape with many 386 Bahamian components and code from the Free Software Foundation. After two public beta releases via FTP, the first official release was FreeBSD 1.0, available via FTP on November 1, 1993 and on CD-ROM on December 30, 1993. This official release was coordinated by Jordan Hubbard, Nate Williams, Rodney W. Grimes and named by David Greenman. Walnut Creek CD-ROM agreed to distribute FreeBSD on CD and gave the project a machine to work on along with a fast internet connection, which Hubbard later said helped stir FreeBSD's rapid growth. A highly successful FreeBSD 1.1 release followed in May 1994. However, there were legal concerns about the BSD Net/2 release source code used in 386 Bahamian. After a lawsuit between then Unix copyright owner Unix System Laboratories, and the University of California, Berkeley, the FreeBSD project re-engineered most of the system using the 4.4 Bahamian light release from Berkeley, which, owing to the lawsuit, had none of the AT&T source code earlier BSD versions contained, making it an unbootable operating system. Following much work, the unencumbered outcome was released as FreeBSD 2.0 in January 1995. FreeBSD 2.0 featured a revamp of the original Carnegie Mellon University Mac virtual memory system, optimized for performance under high loads. This release introduced the FreeBSD port system, which made downloading, building and installing third-party software very easy. By 1996, FreeBSD had become popular among commercial and ISP users, powering sites like Walnut Creek CD-ROM, Yahoo! And Hotmail. The last release along the two-stable branch was 2.2.8 in November 1998. FreeBSD 3.0 brought many more changes, including the switch to the ELF binary format. Support for SMP systems and the 64-bit Alpha platform were added. The three-stable branch ended with 3.5.1 in June 2000. From the early days of the project's inception, a company named Walnut Creek CD-ROM, upon the suggestion of the two FreeBSD developers, agreed to release the operating system on CD-ROM. In addition to that, the company employed Jordan Hubbard and David Greenman, ran FreeBSD on its servers, sponsored FreeBSD conferences and published FreeBSD-related books, including The Complete FreeBSD by Greg Lee. By 1997, FreeBSD was Walnut Creek's most successful product. The company itself later renamed to the FreeBSD MAL. In 2005, FreeBSD was characterized as the unknown giant among free operating systems. Features: networking. FreeBSD's TCP/IP stack is based on the 4.2 Bahamian implementation of TCP/IP, which greatly contributed to the widespread adoption of these protocols. FreeBSD also supports IPv6, SCTP, IPsec, and wireless networking. The IPv6 and IPsec stacks were taken from the KAME project. Also, FreeBSD supports IPX and AppleTalk protocols, but they are considered old and it is planned to drop support of them as of FreeBSD 11.0. As of FreeBSD 5.4, support for the Common Address Redundancy Protocol was imported from the OpenBSD project. CARP allows multiple nodes to share a set of IP addresses. So if one of the nodes goes down, other nodes still can serve the requests. Storage: FreeBSD has several unique features related to storage. Soft updates can protect the consistency of the UFS file system in the event of a system crash. File system snapshots allow an image of a UFS file system at an instant in time to be efficiently created. Snapshots allow reliable backup of a live file system. GEOM is a modular framework that provides RAID, full disk encryption, journaling, concatenation, caching, and access to network-backed storage. GEOM allows building of complex storage solutions combining these mechanisms. From 7.0 onward, FreeBSD supports the ZFS file system. ZFS was previously an open-source file system that was first developed by Sun Microsystems, but when Oracle acquired Sun, ZFS became a proprietary product. However, the FreeBSD project is still developing and improving its ZFS implementation. FreeBSD provides two frameworks for data encryption, GBDE and Jelly. Both GBDE and Jelly operates at the disk level. GBDE was written by Paul Hennenkamp and is distributed under the two-clause BSD license. Jelly is an alternative to GBDE that was written by Paul Jacob de Witte and first appeared in FreeBSD 6.0. Security: FreeBSD provides several security-related features including access control lists, security event auditing, extended file system attributes, fine-grained capabilities and mandatory access controls. These security enhancements were developed by the Trusted BSD project. The project was founded by Robert Watson with the goal of implementing concepts from the Common Criteria for Information Technology Security Evaluation and the Orange Book. This project is ongoing and many of its extensions have been integrated into FreeBSD. The project is supported by a variety of organizations, including the DARPA, NSA, Network Associates Laboratories, Safe Report Network Services, the University of Pennsylvania, Yahoo! McAfee Research, Sparta, Apple Computer, Encircle Network Security, Google, the University of Cambridge Computer Laboratory, and others. The project has also ported the NSA's Flask-TE implementation from SELinux to FreeBSD. Other work includes the development of OpenBSM, an open-source implementation of Sun's Basic Security Module API and audit log file format, which supports an extensive security audit system. This was shipped as part of FreeBSD 6.2. Other infrastructure work in FreeBSD performed as part of the Trusted BSD project has included SYN cookies, GEOM and OpenPAM. While most components of the Trusted BSD project are eventually folded into the main sources for FreeBSD, many features, once fully matured, find their way into other operating systems. For example, OpenPAM and UFS2 have been adopted by NetBSD. Moreover, the Trusted BSD Mac framework has been adopted by Apple for OS X. Much of this work was sponsored by DARPA under DARPA SPOR contract N66001-01C8035. FreeBSD ships with three different firewall packages, IPFW, PF and UpFilter. IPFW is FreeBSD's native firewall. PF was taken from OpenBSD and UpFilter was ported to FreeBSD by Darren Reed. Taken from OpenBSD, the OpenSSH program was included in default install. OpenSSH is a free implementation of SSH protocol and is a replacement for Telnet. Unlike Telnet, OpenSSH encrypts all information. Portability: FreeBSD has been ported to a variety of processor architectures. The FreeBSD project organizes architectures into tiers that characterize the level of support provided. Tier 1 architectures are mature and fully supported. Tier 2 architectures are undergoing major development. Tier 3 architectures are experimental or are no longer under active development, and Tier 4 architectures have no support at all. As of March 2014, FreeBSD has been ported to the following architectures: third-party software. FreeBSD has a repository of over 24,000 applications that are developed by third parties outside of the project itself. In general, the project itself does not develop this software, only the framework to allow these programs to be installed. Applications may be installed either from source, if its licensing terms allow such redistribution, or as compiled binaries if allowed. The ports collection supports the latest release on the current and stable branches. Older releases are not supported and may or may not work correctly with an up-to-date ports collection. Ports and packages. Each application in the ports collection is installed from source. Each ports make file automatically fetches the application source code either from a local disk, CD-ROM or via FTP, unpacks it on the system, applies the patches, and compiles. This method can be very time-consuming as compiling large packages can take hours, but the user is able to install a customized program. For most ports, pre-compiled binary packages also exist. This method is very quick as the whole compilation process is avoided, but the user is not able to install a program with customized compile time options. In FreeBSD 10.0, a new package manager, called pkgng, was introduced. pkgng is a replacement for traditional package add, package create, package delete, package info, package updating, and package version commands. It has functionality similar to apt and yum. It includes installation and upgrades from both source and with pre-built binary packages. PackageKit also supports the FreeBSD ports collection as an accepted repository. Jails. First introduced in 4X, a FreeBSD jail is a security mechanism and an implementation of operating system-level virtualization that enables the user to run multiple instances of a guest operating system on top of a FreeBSD host. Jails are enhanced version of traditional triad mechanism. A process that runs in a jail is unable to access the resources outside of that jail. Every jail has its own hostname and IP address. It is possible to run multiple jail at the same time. The kernel is shared among all of them, therefore only FreeBSD-built softwares can be run inside a jail. Virtualization. Bive, a new virtualization solution was introduced in FreeBSD 10.0. Bive allows a user to run a number of guest operating systems simultaneously. Other operating systems such as Microsoft Windows and Illumos are planned. Bive was written by Neil Nato and Peter Grehan and was announced in the 2011 BSD-CAN conference for the first time. The main difference between Bive and FreeBSD jails is that jails are an operating system-level virtualization and therefore limited to only FreeBSD guests. But Bive is a Type 2 hypervisor and is not limited to only FreeBSD guests. Compatibility layer with other operating systems. Most software that runs on Linux can run on FreeBSD using an optional built-in compatibility layer. Hence, most Linux binaries can be run on FreeBSD, including some proprietary applications distributed only in binary form. Additionally, FreeBSD provides compatibility layers for several other Unix-like operating systems, in addition to Linux, such as BSD-OS and SVR4. In addition to that, FreeBSD is able to run NetBSD and OpenBSD's binaries, but people usually don't do that and instead, compile those programs directly on FreeBSD. No noticeable performance penalty over native FreeBSD programs has been noted when running Linux binaries, and, in some cases, these may even perform more smoothly than on Linux. However, the layer is not altogether seamless, and some Linux binaries are unusable or only partially usable on FreeBSD. There is support for system calls up to version 2.6.16, available since FreeBSD 7.0. However, there is currently no support for running 64-bit Linux binaries. As of 2013, there are plans for supporting them in FreeBSD 10. This compatibility layer is not an emulation. Linux's ABIs are implemented in the FreeBSD's kernel and hence, Linux binaries are treated same as FreeBSD's native binaries. FreeBSD has implemented a number of Microsoft Windows native APIs. With the help of these APIs, FreeBSD is able to run Windows-only network drivers. Kernel: FreeBSD's kernel provides support for some essential tasks such as managing processes, communication, booting and file systems. FreeBSD has a monolithic kernel, with modular design. Different parts of the kernel such as drivers, are designed as modules. The user can load and unload these modules at any time. ULE is the default scheduler in FreeBSD since version 7.1, it supports SMP and SMT. The FreeBSD kernel has also a scalable event notification interface, named KQUEUE. It has been ported to other BSD derivatives such as OpenBSD, NetBSD. Originally, FreeBSD used a M-N threading model. This model is the best threading model in the theory, but it is hard to implement and few operating systems supports it. Although FreeBSD's implementation of this model worked, it did not perform well, so FreeBSD started using a 1-1 threading model, called LIBTHR. Documentations and support: FreeBSD's official documentations, consists of its handbooks, manual pages, mailing list archives, FAQs and a variety of articles, mainly maintained by the FreeBSD Documentation Project and are available at FreeBSD's homepage. Official documentations are translated into several languages. All official documentations are released under the FreeBSD Documentation License, a permissive non-copyleft free documentation license that is compatible with the GNU FDL. FreeBSD's documentations are described as high quality. The FreeBSD project maintains a variety of mailing lists. Among the most popular mailing list are FreeBSD Question, FreeBSD Newbies and FreeBSD Hackers. Development: FreeBSD is developed by a volunteer team around the world. The developers uses Internet for all communications and even they may not met each other in person. There are also some user groups around the world. In addition to these user groups, an annual conference, called BSDCon, is held by Usenix, though BSDCon is not a FreeBSD-specific conference and deals with technical aspects of all BSD operating systems, including OpenBSD and NetBSD. In addition to BSDCon, two other annually held conferences, EuroBSDCon and AsiaBSDCon also takes place in Europe and Japan respectively. Governance structure: the FreeBSD project is run by FreeBSD committers, or developers who have SVN commit access. There are several kinds of committers, including source committers, doc committers and ports. Every 2 years the FreeBSD committers select a 9-member FreeBSD core team who are responsible for overall project direction, setting and enforcing project rules and approving new commit bits, or the granting of SVN commit access. A number of responsibilities are officially assigned to other development teams by the FreeBSD core team, including responsibility for security advisories, release engineering and managing the ports collection. Developers may give up their commit rights to retire or for safekeeping after a period of a year or more of inactivity, although commit rights will generally be restored on request. Under rare circumstances commit rights may be removed by core team vote as a result of repeated violation of project rules and standards. The FreeBSD project is unusual among open source projects in having developers who have worked with its source base for over 10 years before its release in 1993, owing to the involvement of a number of past University of California developers who worked on BSD at the Computer Systems Research Group. Branches: FreeBSD developers maintain at least 2 branches of simultaneous development. The current branch always represents the bleeding edge of FreeBSD development. A stable branch of FreeBSD is created for each major version number, from which release are cut about once every 4–6 months. If a feature is sufficiently stable and mature, it will likely be backported to the stable branch. FreeBSD's development model is further described in an article by Niklas Says. Foundation. FreeBSD development is supported in part by the FreeBSD Foundation. The Foundation is a non-profit organization that accepts donations to fund FreeBSD development. Such funding has been used to sponsor developers for specific activities, purchase hardware and network infrastructure, provide travel grants to developer summits, and provide legal support to the FreeBSD project. License. FreeBSD is released under a variety of open-source licenses. The kernel code and most newly created code is released under the 2-clause BSD license, which allows everyone to use and redistribute FreeBSD as they wish. This license was approved by Free Software Foundation and Open Source Initiative is a free software and open source license respectively. Free Software Foundation described this license as a lax, permissive non-copyleft free software license, compatible with the GNU GPL. There are parts released under 3 and 4-clause BSD licenses, as well as Beoware license. Some device drivers include a binary blob, such as the Aferas HAL of FreeBSD versions before 7.2. Some of the code contributed by other projects is licensed under GPL, LGPL, ISC or CDDL. All the code licensed under GPL and CDDL is clearly separated from the code under liberal licenses, to make it easy for users such as embedded device manufacturers to use only permissive free software licenses. ClangBSD aims to replace some GPL dependencies in the FreeBSD base system by replacing the GNU compiler collection with the BSD licensed LLVM Clang compiler. ClangBSD became self-hosting on April 16, 2010, an important landmark for further independent development. Logo. For many years FreeBSD's logo was the generic BSD daemon, also called Beastie, a distorted pronunciation of BSD. First appearing in 1976 on Unix T-shirts purchased by Bell Labs, the more popular versions of the BSD daemon were drawn by animation director John Lasseter beginning in 1984. Several FreeBSD-specific versions were later drawn by Tozumi Hosokawa. Through the years Beastie became both beloved and criticized as perhaps inappropriate for corporate and mass-market exposure. Moreover, it was not unique to FreeBSD. In lithographic terms, the Lasseter graphic is not line art and often requires a screened, 4-color photo offset printing process for faithful reproduction on physical surfaces such as paper. Moreover, the BSD daemon was thought to be too graphically detailed for smooth size scaling and aesthetically over-dependent upon multiple color gradations, making it hard to reliably reproduce as a simple, standardized logo in only 2 or 3 colors, much less in monochrome. Because of these worries, a competition was held and a new logo designed by Anton K. Gurel, still echoing the BSD daemon, was released on October 8, 2005. Meanwhile, Lasseter's much-known take on the BSD daemon carries forth as the official mascot of the FreeBSD project. The name FreeBSD was coined by David Greenman on June 19, 1993, other suggested names were BSD-FREE86, and Free86BSD. FreeBSD's slogan is "The Power to Serve," which is a registered trademark for the FreeBSD Foundation. Derivatives. There are a number of software distributions based on FreeBSD including PCBSD, FreeSPI, Frenzy, GhostBSD, MonoWall, pfSense, FreeNAS, NAS4Free, Auths of Xilux. All these distributions have no or only minor changes when compared with the original FreeBSD base system. The main difference to the original FreeBSD is that they come with pre-installed and pre-configured software for specific use cases. This can be compared with Linux distributions, which are all binary compatible because they use the same kernel and also use the same basic tools, compilers and libraries, while coming with different applications, configurations and branding. Besides these distributions there is Dragonfly BSD, a fork from FreeBSD 4.8 aiming for a different multiprocessor synchronization strategy than the one chosen for FreeBSD 5 and development of some microkernel features. It does not aim to stay compatible with FreeBSD and has huge differences in the kernel and basic user land. A wide variety of products are directly or indirectly based on FreeBSD. Examples of embedded devices based on FreeBSD include Citrix NetScalers, F5 Networks is 3DNS version 3 Global Traffic Manager and EdgeFX version 1 Web Cache, iImport Network Security Appliances, Juno's network operating system by Juniper Networks used in their routers, switches and security devices, KACE Networks is KBOX 1000 and 2000 series appliances and the virtual KBOX appliance, and Circle Network Security's IP360, NetApp's Data ONTAP8X and the now superseded ONTAP-GX, NETASQ security appliances, Nokia's Firewall operating system, Panasys's and Isilon Systems' cluster storage operating systems, the PlayStation 3, the PlayStation 4, SandWinds. Network policy control products, Sophos' email appliance Street Bernard software iPrism web filtering appliances, Panasonic's 2010 TV models, Blue Coat's Proxy SG1 acceleration appliances partially derived from FreeBSD, Netflix's Open Connect appliance, the Weather Channel's and Telestar local forecast computer runs FreeBSD. Other operating systems such as Linux and the RTOS VxWorks contain code that originated in FreeBSD. Debian, known primarily for using the Linux kernel, also maintains GNU KFreeBSD, combining the GNU user space and C library with the FreeBSD kernel. Darwin, the core of Apple OS X, borrows FreeBSD a Euro unregistered trademark S virtual file system. Network Stack and components of its user space are the Open Darwin project, a spin-off of a PLE Euro unregistered trademark S Darwin operating system, also included substantial FreeBSD code thanks to the permissive FreeBSD license. Much of FreeBSD now also forms the basis of Apple OS X and OS X Server. Mac OS X Server includes the latest technological advances from the open-source BSD community originally developed at the University of California, Berkeley. The BSD distribution is the foundation of most Unix implementations today. A Mac OS X Server is based largely on the FreeBSD distribution and includes the latest advances from this development community. FreeBSD on Raspberry Pi single-board computers. In addition, initial work has been done to port FreeBSD to run on Raspberry Pi single-board computers with ARM11 SoC hardware. Installers, sysinstall. For a long time, FreeBSD used the sysinstall program as its main installer. It uses a text user interface, and is divided into a number of menus and screens that can be used to configure and control the installation process. It can also be used to install ports and packages as an alternative to the command line interface. As of FreeBSD 9, sysinstall has been replaced by xdinstall. It was written in C by Jordan Hubbard, is curses-based and first appeared in FreeBSD 2.0. The utility is now considered deprecated. Xdinstall. The xdinstall utility is a lightweight replacement for sysinstall, which replaced the sysinstall utility in FreeBSD 9.0. It was written in Sys and is more extendable than FreeBSD's old installer. According to OS News, it has lost some features while gaining others, but it is a much more flexible design, and will ultimately be significant improvement. PCBSD installer. The PCBSD installer aims to create a user-friendly graphical installer for FreeBSD and FreeBSD-derived systems. Unauthorized access to FreeBSD's servers. On November 2012, the FreeBSD security team announced that hackers gained unauthorized access on 2 of the project's servers. These servers were turned off immediately. More research demonstrated that the first unauthorized access by hackers occurred on September 19. Apparently hackers gained access to these servers by stealing SSH keys from FreeBSD's developers, not by exploiting a bug in the operating system itself. These two hacked servers were part of the infrastructure used to build third-party software packages. The FreeBSD security team checked the integrity of the binary packages and announced that no unauthorized change was made to the binary packages, but they stated that they can't guarantee the integrity of packages that was downloaded between September 19 and November 11. Version history. FreeBSD 1, released in November 1993. 1.1.5.1 was released in July 1994. FreeBSD 2, 2.0 release was announced on November 22, 1994. The final release of FreeBSD 2, 2.2.8 release, was announced on November 29, 1998. FreeBSD 2.0 was the first FreeBSD to be claimed legally free of AT&T Unix code with approval of Novell. It was the first version to be widely used at the beginnings of the spread of Internet servers. FreeBSD 3, FreeBSD 3.0 release was announced on October 16, 1998. The final release, 3.5 release, was announced on June 24, 2000. FreeBSD 3.0 was the first branch able to support symmetric multiprocessing systems, using a giant lock. USB support was first introduced with FreeBSD 3.1, and the first gigabit network cards were supported in 3.2 logo release. FreeBSD 4, 4.0 release appeared in March 2000 and the last full stable branch release was 4.11 in January 2005, supported until January 31, 2007. FreeBSD 4 was lauded for its stability and was a favorite operating system for ISPs and web hosting providers during the first dot-com bubble, and is widely regarded as one of the most stable and high-performance operating systems of the whole Unix lineage. Among the new features of FreeBSD 4, KQUEUE 2 was introduced. FreeBSD 5, after almost 3 years of development, the first 5.0 release in January 2003 was widely anticipated, featuring support for advanced multiprocessor and application threading, and for the UltraSPARC and IA64 platforms. The first 5 stable release was 5.3. The last release from the 5 stable branch was 5.5 in May 2006. The largest architectural development in FreeBSD 5 was a major change in the low-level kernel locking mechanisms to enable better symmetric multiprocessor support. This released much of the kernel from the MP lock, which is sometimes called the giant lock. More than one process could now execute in kernel mode at the same time. Other major changes included an native threading implementation called kernel scheduled entities. In principle, this is similar to scheduler activations. Starting with FreeBSD 5.3, KSE was the default threading implementation until it was replaced with a 1.1 implementation in FreeBSD 7.0. FreeBSD 5 also significantly changed the block I/O layer by implementing the GEOM modular disk I/O request transformation framework contributed by Paul Henningkamp. GEOM enables the simple creation of many kinds of functionality, such as mirroring and encryption. This work was supported through sponsorship by DARPA. While the early versions from the 5X were not much more than developer previews, with pronounced instability, the 5.4 and 5.5 releases of FreeBSD confirmed the technologies introduced in the FreeBSD 5X branch had a future in highly stable and high-performing releases. FreeBSD 6, FreeBSD 6.0 was released on November 4, 2005. The final FreeBSD 6 release was 6.4, on November 11, 2008. These versions continue work on SMP and threading optimization along with more work on advanced 802.11 functionality, trusted BSD security event auditing, significant network stack performance enhancements, a fully preemptive kernel and support for hardware performance counters. The main accomplishments of these releases include removal of the giant lock from VFS, implementation of a better performing optional libthr library with 1.1 threading and the addition of a basic security module audit implementation called OpenBSM, which was created by the Trusted BSD project and released under a BSD-style license. FreeBSD 7. FreeBSD 7.0 was released on February 27, 2008. The most recent and final FreeBSD 7 release was 7.4, on February 24, 2011. New features include SCTP, UFS journaling, an experimental port of Sun's ZFS file system, GCC4, improved support for the ARM architecture, gMalloc, and major updates and optimizations relating to network, audio, and SMP performance. Benchmarks have shown significant speed improvements over previous FreeBSD releases as well as Linux. The new ULE scheduler has seen much improvement, but a decision was made to ship the 7.0 release with the older 4 Bahamian dollars scheduler, leaving ULE as a kernel-compiled time-tunable. In FreeBSD 7.1, ULE was the default for the i386 and 64 Armenian DRAMs architectures. Starting from version 7.1, DTRACE was also integrated, and FreeBSD 7.2 brought support for multi-IPv4/IPv6 jails. Code supporting the DEC Alpha architecture was removed in FreeBSD 7.0. FreeBSD 8. FreeBSD 8.0 was formally released on November 25, 2009. FreeBSD 8 was branched from the trunk in August 2009. It features superpages, XenDomu support, network stack virtualization, stack smashing protection, TTY layer rewrite, much updated and improved ZFS support, a new USB stack with USB 3.0 and XHCI support added in FreeBSD 8.2, multicast updates including IGMPv3, a rewritten NFS client server introducing NFS v4, and AES acceleration on supported Intel CPUs. Inclusion of improved device map extensions enables implementation of a 64-bit NVIDIA display driver for the x86-64 platform. A pluggable congestion control framework, and support for the ability to use DTRACE for applications running under Linux emulation were added in FreeBSD 8.3. FreeBSD 8.4 is the most recent release from the FreeBSD 8 series, and was formally released on June 7, 2013. FreeBSD 9. FreeBSD 9.0 was released on January 12, 2012. Key features of the release include a new installer, UFS journaling, ZFS version 28, userland DTRACE, NFS v4 compatible NFS server and client, USB 3.0 support, support for running on the PlayStation 3, Capsicum sandboxing, and LLVM 3.0 in the base system. The kernel and base system can be built with Clang, but FreeBSD 9.0 still uses GCC 4.2 by default. The PlayStation 4 video game console uses a derived version of FreeBSD 9.0, which Sony Computer Entertainment dubbed ORBISOs. FreeBSD 9.1 was released on December 31, 2012. FreeBSD 9.2 was released on September 30, 2013. FreeBSD 9.3 was released on July 16, 2014. FreeBSD 10. On January 20, 2014, the FreeBSD release engineering team announced the availability of FreeBSD 10.0 release. Key features include the deprecation of GCC in favor of Clang, a new ISTC implementation, FightIO drivers for out-of-the-box KVM support, and a Fuse implementation. Timeline. The timeline showed that the span of a single release generation of FreeBSD lasts around 5 years. Since the FreeBSD project makes effort for binary backward compatibility within the same release generation, this allows users 5+ years of support, with trivial to easy upgrading within the release generation. See also: BAPA Euro BSD plus Apache plus PostgreSQL plus Perl Python, BSD descendants, comparison of BSD operating systems, comparison of operating system kernels, comparison of operating systems, Marshall Kirkmac CUSIC, Computer Systems Research Group, how does one patch KDE2 under FreeBSD? References. Notes. External links, official website, official forums, Official Wiki, Official FreeBSD Handbook, FreeBSD a Distro Watch.